Imagine you are standing at night, somewhere far from any city, with a sky so dark and clear it looks almost physical above you. You tilt your head back. Saturn is up there, unmistakable, not a point of light like the stars, but something warmer, steadier, faintly amber. Even to the naked eye, there is something about it that feels deliberate, as if someone placed it there on purpose, like an ornament hung too carefully to be accidental. Now imagine you knew what was actually orbiting that point of light. Not the rings, though the rings alone are breathtaking, 1 billion to billion particles of ice suspended in a razor-thin halo you could drive across at highway speed and be done with in less than an hour. No, imagine you could see the moons. All of them. Hundreds of shapes tumbling in the dark, some barely larger than a small city, some enormous and ancient and hiding oceans beneath their frozen crusts. They orbit in every direction, at every angle, some moving with Saturn's rotation and some moving against it, backwards and tilted, as though they wandered in from somewhere else entirely, because, as it turns out, they did. Stand there long enough, in that dark field, and let yourself feel the weight of it. Something happened around Saturn, something enormous and violent, and it left behind a scar we are only now beginning to read. For as long as telescopes have existed, Saturn has been the king of moons. We always knew that. We accepted it the way we accept most things about the solar system, as a settled fact, part of the furniture of space. Saturn has a lot of moons. Fine, we counted a few dozen, then 100, then a little more. Jupiter, its larger neighbor, had fewer. That seemed right. Larger planet, more moons, except that is not quite how it works. And the numbers themselves have never really sat still. But here is what nobody expected on the morning of the 11th of March 2025. The International Astronomical Union's Minor Planet Center, the official body responsible for cataloging the small objects of our solar system, published a series of bulletins that very nearly doubled what we thought. In a single announcement, 128 new moons of Saturn were confirmed. 128, not a handful, not a dozen. A number so large that it brought Saturn's total to 274 known moons, more than all the other planets in our solar system combined. Jupiter, the next closest competitor, has 95. Based on our projections, said Dr. Edward Ashton, the lead researcher behind the discovery and a postdoctoral fellow at Academia Sinica in Taiwan. I don't think Jupiter will ever catch up. That sentence should stop you, because what Ashton is implying, what the data behind that announcement is quietly screaming, is not just that Saturn has a lot of moons. It is that we need to ask why. Why this planet? Why this many? Why so small? Why going the wrong way? And why, if you look carefully at the math, all of this seems to point toward a catastrophe that happened almost exactly when the dinosaurs were walking the Earth. The team behind the discovery includes Dr. Brett Gladman of the University of British Columbia, who essentially invented the modern era of CCD detection for irregular planetary satellites back in the late 1990s, along with Dr. Grabston, Mike Alexanderson of the Harvard-Smithsonian Center for Astrophysics, and Dr. Jean-Marc Petit of the Observatoire de Besançon in France. They used the Canada-France-Hawaii telescope atop Mauna Kea, one of the most powerful optical telescopes in the world, and applied a method called shift and stack, which combines dozens of long exposure images taken over many nights, effectively slowing the sky down to the speed of Saturn and allowing the faintest possible objects to reveal themselves against the background stars. They observed Saturn repeatedly between 2019 and 2021, confirmed 64 new moons from that data, and then knowing there were more, went back in 2023 for 3 additional months. That second campaign yielded 128 more. All 128 are what astronomers call irregular moons. That word, irregular, is doing a lot of work here. It means these objects are not like our moon, not like Titan, not like the dozen or so large, well-behaved satellites that orbit Saturn in neat circular paths close to the planet. The new moons orbit far out between roughly 10 million and 30 million kilometers from Saturn, which is so distant that some of them take years to complete a single orbit, and which places them well beyond Saturn's rings and its inner family of recognized worlds. Imagine Saturn's rings as a city at the center of a vast, empty landscape. The major moons Titan, Enceladus, Rhea, Mimas are the suburbs, the neighborhoods most people have heard of. These 128 new moons are something else entirely. They are wanderers camping out in the surrounding wilderness, ranging over enormous territories, following paths so elongated and tilted they seem to belong to a different system. And here's the thing that makes those orbital paths so strange. Most of them are retrograde. They orbit backwards, opposite to Saturn's rotation, opposite to the direction the planet formed. A moon that forms naturally, from the same swirling disk of gas and dust that built the planet itself, always moves in the same direction as that disk rotated. Retrograde orbits are a signature. They are the fingerprint of an object that did not form here. Something else brought these rocks into Saturn's gravitational embrace, and something else more recently, far more recently, shattered them. These moons are a few kilometers in size, Gladman explained in a statement, and are likely all fragments of a smaller number of originally captured moons that were broken apart by violent collisions, either with other Saturnian moons or with passing comets. A few kilometers. To give you a sense of scale, our moon is roughly 3,474 kilometers across. The average of Saturn's new moons is somewhere between 2 and 3 kilometers smaller than many cities, smaller than some mountains, barely large enough to be seen from a spacecraft in close approach. Each one of them earns the official title of moon. Each one of them is orbiting a planet 1.4 billion kilometers from the Sunday, and there may be thousands more we cannot yet see. But that is not the most unsettling part. When the team analyzed the orbital groups of the new moons, they found that some families of objects were clustered in ways that only make sense if they all came from the same original body, a larger moon that was destroyed and scattered into fragments. One of these families, named Mundalfari after a figure from Norse mythology, contains 47 of the newly confirmed moons. The orbital properties of this group are distinctive enough that the team was able to calculate approximately when the collision that created them must have occurred. The answer is a date at most 100 million years ago. Not billion, 100 million. 100 million years ago, the continents had not yet fully separated into their modern shapes. The Atlantic Ocean was narrow and young, and the dominant land animals on Earth were dinosaurs, while a Tyrannosaurus rex stalked its prey through what would later become the Badlands of Montana. A moon, a body perhaps 100 kilometers across, large enough to have mountains and valleys of its own, was being torn apart somewhere in the outer dark of the Saturn system. The math here is specific, and the specificity matters. Gladman notes that the collision cannot be older than 100 million years, because if it were, the resulting fragments would have spent so long colliding with one another that most of them would have been ground down to invisibility by now. We would not be able to see them. The fact that we can, the fact that 47 of them are still scattered across recognizable orbital paths, means the destruction is cosmically recent. The scar is still fresh. And then Webb found something else. Or rather, scientists found something extraordinary when they began asking a question the new moon discoveries made impossible to ignore. Is this collision connected to Saturn's rings? This is where the story becomes genuinely difficult to contain within the neat boundaries of a single discovery. Because the same Cassini spacecraft that spent 13 years orbiting Saturn between 2004 and 2017 measured something that continues to disturb planetary scientists. Saturn's famous rings appear to be surprisingly young, not as old as Saturn itself, which formed around 4.5 billion years ago along with the rest of the solar system. Young. The Cassini data, analyzed in painstaking detail over the years since the mission ended with the probe's planned plunge into Saturn's atmosphere in September 2017, suggests the rings are somewhere between 100 and 400 million years old, which places their formation right in the same geological era as the collision that produced the Mundalfari family, the same era as the dinosaurs. These two things, the fragmented moons and the glittering rings, appear to be traces of the same catastrophe. That hypothesis is not yet proven, and scientists are careful about that. There are researchers, among them Aurélien Creda of the Université Côte d'Azur in France, who argue that the rings could in fact be ancient, as old as the solar system, and that we are misreading the evidence. The debate is real, and it matters. But the emerging picture, supported by increasingly detailed computer simulations and deepened further by a remarkable study from the SETI Institute published in February 2026, is one of a system that experienced something close to a catastrophe within the memory of geological Earth. The SETI Institute study, led by Dr. Matija Chuk, proposes something even more dramatic. that Saturn's largest moon, Titan, the one with the thick atmosphere and the methane lakes, the one that looks more like a young Earth than anywhere else in the solar system, may itself be the product of a moon-moon merger. In this model, two older moons, a proto-Titan and a body roughly 1,000 times more massive than anything in the Mundilfari family, collided hundreds of millions of years ago. The energy from that impact was so immense, it would have resurfaced Titan entirely, erasing billions of years of impact craters and replacing them with the relatively smooth landscape the Cassini cameras recorded. The eccentric, drifting orbit Titan currently follows a mystery that has nagged at astronomers for decades would be the lingering momentum of that collision still working itself out. And in the cascade that followed, Titan's newly tilted orbit gradually disturbed its inner neighbors, nudging some of the medium-sized inner moons into resonances and then into collisions of their own. That secondary wave of destruction may have produced the debris that eventually became the rings. One catastrophe. Many consequences. Still visible now. In simulations where the extra moon became unstable, said Chuk, Hyperion was often lost and survived only in rare cases. Hyperion's Saturn's small, chaotically tumbling, sponge-textured moon may be not an original inhabitant of the Saturn system at all, but a survivor of that same upheaval, a chunk of debris from the original merger that managed to hold itself together while everything around it fell apart. NASA's Dragonfly mission, a nuclear-powered rotorcraft lander currently scheduled to reach Titan in 2034, is being watched with considerable attention by scientists invested in this question. If Titan's surface chemistry and geology show the signatures of a violent resurfacing event, young rocks where ancient craters should be, isotopic ratios, consistent with material from a foreign moon, it would constitute the closest thing to direct evidence this hypothesis has ever had. But perhaps the most disquieting implication of all this is not what it tells us about Saturn's past. It is what it tells us about Saturn right now. Because while scientists were cataloging the 128 new moons and building their models of ancient catastrophes, University of Iowa physics and astronomy professor Allison Janes said something in March 2025 that deserves to be repeated slowly. "I think there are more," she told reporters. "This is one of the cases of the closer you look, the more you see. The closer you look, the more you see." Dr. Ashton himself acknowledged that current technology is likely at the edge of what can be detected from Earth. But the edge of current technology is not the edge of what exists. Saturn's irregular moon population almost certainly extends down to objects far smaller than what any telescope can currently resolve. Rocks a few hundred meters across, perhaps smaller, cascading in their complex orbits through the outer reaches of the planet's gravitational domain. There may be tens of thousands of them, hundreds of thousands, and in the middle of all that silent violence, there is Enceladus, small enough to fit inside the boundaries of a medium-sized country just 500 kilometers across. Smaller than the state of Arizona, Enceladus is one of the 24 moons of Saturn with a regular, well-behaved prograde orbit, suggesting it formed with the original system billions of years ago. And from cracks near its south pole, it is doing something extraordinary. It is erupting. Water vapor, ice particles, organic molecules, molecular hydrogen. The plumes reach thousands of kilometers into space. The Cassini mission flew through them and tasted what they contained. Water with the chemical fingerprints of a hydrothermal ocean on the seafloor below the ice. In December 2023, scientists announced the detection of hydrogen cyanide in those plumes, a molecule that, on Earth, is considered a potential precursor to the chemical processes that gave rise to life. The same planet that hosts the aftermath of catastrophic destruction also hosts, in a small and faithful little world, what may be the most compelling address for life in the solar system. That juxtaposition is something I find genuinely difficult to sit with. Enceladus is surrounded by the wreckage of collisions. It orbits inside the rings that are themselves debris. It exists within a system that was, relatively recently, torn apart. And it has been patiently building chemistry for billions of years. There is something in all of this that feels like a lesson about the nature of destruction and time, though I am not sure we are in a position yet to receive it cleanly. When we look at Saturn and say 274 moons, we are not describing a planet that happened to capture a lot of rocks. We are reading the residue of a history we did not witness, a sequence of collisions and mergers and collapses that unfolded over billions of years and left behind everything we see today. The rings, the moons, the tilted axis, the chaotic little wanderers orbiting backwards in the dark. It is not chaos, exactly. It is evidence. It is a record. What science does, at its most fundamental level, is exactly this. It looks at what survived and works backwards toward what happened. It reads the arrangement of fragments and reconstructs the shape of the thing that broke. 128 small rocks, scattered across the outer Saturn system in similar orbits, tilted the same way, moving in the same retrograde direction. They are not 128 separate stories. They are one story, told in pieces. What unsettles me most is this. We are very likely living at the precise moment in Saturn's history when the rings are at their most spectacular. They are young. They are bright. They are draining, slowly, falling back into the planet at a rate Cassini measured in tons per second. In somewhere between 100 and 300 million years, they may be gone entirely. The dinosaurs never saw them. Whoever comes after us, if anyone does, may not see them either. We are here exactly now, at the window. That may be the strangest number in this entire story. Not 274, not 128, not 100 million years. The strangest number is this. We have been watching Saturn for less than 400 years. And in that vanishingly small sliver of time, we have managed to arrive at exactly the right moment to see it in what may be its most extraordinary phase. Whether that says something about luck or inevitability or the strange anthropic logic of observers, I genuinely do not know. Thanks for watching, and I'll see you in the next one.